Hello, in this video we're going to go through how to do a multiple linear regression using G-power. So our research scenario, does grit and age predict self-efficacy? So both grit and age are our predictors. So we have two predictors and they are both numeric. And we're trying to predict self-efficacy, which is also numeric and is our response variable. So we have three numeric variables with two predictors and one response variable. Let's go ahead and take a look at G-power itself. So here is G-power. It always just defaults to the t-test, but in this case we do want the f-test. And then when you pull it down, we want this one, the linear multiple regression fixed model r-squared deviation from 0. So this is the one right there that we want. We are always doing a priori because we are always trying to figure out our minimum sample size before we collect the data. So it's always a priori. Our effect size just defaults. If we mouse over, we can see it defaults to that medium, which is exactly what we want. So we're going to leave that alone. Our alpha error of probability is 0.05, which we're also going to leave alone. But then our power, you can see that the power, it's normally set to 0.95. I think it's just because I've been doing a lot of these that it went ahead and did 0.80, but normally it's going to have that 0.95, and you do need to change it to 0.8 or 0.80. And that's just that normal default variable that we use for power. If you remember back to the lecture, I did on G-power and what power is and effect size and alpha error and all of that. Power just is defaulted to 0.8, so we do need to have it to 0.8 or 0.80. And I like 0.80 just, I don't know, because that's what I normally say, but it really doesn't matter. Either way. And then for number of predictors, we do need to change our number of predictors to 2. Now, if you looked at linear regression, then you would have seen that the only difference between a linear regression and the multiple regression, it uses the exact same statistical test, the exact same values. The only difference is the number of predictors, because if you only have one predictor, it's a linear regression. So if you are doing a multiple regression, you will have 2 or more predictors. In this case, we do have 2 predictors, grit and age. So we're going to go ahead and click calculate, and you can see that it's 68. So the minimum sample size for a multiple regression where you have 2 predictors is 68. Now, if we increase that, let's say we had 3 predictors, so 3 numeric variables, you can see it just kind of keeps going up. There's 77. If we go up to 4, 85. So it's just going to kind of keep easing up a little more with our number of predictors. But in this case, we did only have 2 predictors, so our minimum sample size is 68. Now in terms of writing this up, we're going to have these written results for the discussion. So for the discussion this week, but also if you were doing a quantitative IRB or a quantitative chapter 3, you would need these G-power or this G-power information there as well. So we've got our research question scenario. Does grit and age predict self-efficacy? Our statistical test is a multiple regression. Especially for our discussion, but even for an IRB or Chapter 3, you do need to describe or explain what is the purpose of using G-power. Now, we went over that in that previous video where I was talking about, what is power and what is minimum sample size and effect size and all of that, but you need to add your own information here with a citation, so with an in-text citation and reference. And then this is kind of that main write-up of the G-power results. For this research, a G-power analysis was done a priori to establish a rigorous sample size. Power is 0.8, effect size 0.15, alpha 0.05. The results from G-power indicate a minimum sample size of 68. Then see Appendix X. And that see Appendix X is important because both for our discussion as well as whether you're doing it for your dissertation, so for the IRB or your Chapter 3, you do have to include this G-power output. So make sure that you do a screenshot of your G-power output so that way you've got it and you can document it both for our discussions or for, if you're doing this for your dissertation. So that is it, and if you have any questions, let me know.